Greetings, science family. We are back and we're going over our quiz review, going through ionic and covalent naming and formula writing. Meaning, can we tell when a formula or a name is ionic or covalent and how? And do we know the proper rules for writing the formulas, but also writing out the names as well? So let's get to it. So if you look, we're just trying to first of all determine if it's ionic or covalent and then properly name it. So let's start with number one. Number one is SO. S is sulfur, O is oxygen. Those are both nonmetals on the right side of the periodic table. So whenever we have two nonmetals, we know that we have something that is covalently bonded, right? Those are all nonmetals. So if this is covalently bonded, what do we know about covalence? That we have to use the prefixes, right? So the mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So when we name this, there's one sulfur, so we'll just call it sulfur. Remember, we don't use mono on the very first one, only the second one. And since there's one oxygen, oxygen's name is going to turn to oxide. And since there's one, we will call it monoxide. So this is going to be sulfur monoxide. Let's take a look at number two. Number two has lithium and chlorine. Lithium is a metal, since it's on the left side of the periodic table. So if there's a metal and a nonmetal, we know that this is ionic. And if it's ionic, we do not use prefixes, we just use the ion names. So if you look on the ion sheet that we have, lithium is just called the lithium ion, so we just name it lithium. And chlorine turns to what we call the chloride ion, so it just becomes chloride. Again, look on your ion sheet to verify that, but we'll just call it lithium chloride. Notice we didn't call it lithium monochloride. We never use prefixes when we use ionic compounds. Next one up, we've got Al2S3. So we have an aluminum in there, a couple of them, and also sulfurs. Well, I know aluminum is a metal, so if it's a metal, this must be an ionic compound. All right, if it's ionic, that means we're just going to name it by its ion names. If I look up aluminum on my ion sheet, it's just named aluminum. Nothing fancy. Notice I didn't put dialuminum. I don't use prefixes if it's ionic. And then there's three sulfurs, but that doesn't matter. Because it's ionic, we don't use prefixes. So sulfur on my ion sheet, its name turns to sulfide. So that's called aluminum sulfide. Next one up is P2S5. That's phosphorus and sulfur. Phosphorus is a nonmetal and so is sulfur. So this is a covalent. I'll just put a C for covalent. If that's the case, for covalent, we are going to name using prefixes. So I have two phosphorus, so I'm going to say diphosphorus. Remember the very first element, we do not change its name. It's not like diphosphide or anything. It's diphosphorus. And then I have 5 sulfurs. So that would be penta, and sulfur becomes sulfide. So pentasulfide. Let me see if I can squeeze that in here. I'm running out of room. I think I got it though. Pentasulfide. All right, nice job. When it's covalent, we use the prefixes. Next up, Fe2O3. Fe is iron, so if there's a metal, it's got to be ionic. Now here's the deal. When I look up on the ion sheet, iron, I notice that there's more than one charge. So that means my iron is going to have a Roman numeral in parentheses. My oxygen, even though there's 3, it's just ionic, so I'm just going to call it oxide, not trioxide. But the question is, what is that Roman numeral going to be down here? Well, we can figure that out really quick. Let's do some side work. There is in this equation 2 irons and 3 oxygens. Now, I don't know the charge on the irons yet, but I do know oxygen is always a 2- charge. So if that's the case, overall, the oxygens give off a -6 charge. If that's the case, what has to be the charge on each iron in order to balance out the -6? Well, they both have to be +3 to give us a +6 so that that positive and negative cancel out. So if that's the case, we must have a positive 3 charge on iron, and that's why we would say it's iron 3. All right? So that's how we figure out what is the Roman numeral. You just break down the formula and figure out what the charge must be. Sweet. Next up, we have SeO3. So we have selenium and oxygen. Selenium is we're going to consider a nonmetal because it's on the right side of the stair step, and oxygen is a nonmetal, so these must be covalent. For covalent, we're going to use prefixes, so we're going to just write the name, selenium or selenium, however you pronounce it, and then 3 oxygens are going to be trioxide. Remember, oxygen you change to oxide because we always end in "ide" for covalence. Next up is zinc and chlorine. Zinc is a metal, so this must be ionic. Looking on my ion sheet, zinc is just called zinc. And even though there's 2 chlorines, if it's ionic, we don't care. We're just going to call it chloride. Because it's not covalent, we're not going to use prefixes. Coming up is KrF4. If you look, Kr is krypton. Krypton is a nonmetal, and so is fluorine. So this is going to be a covalent bond. Now, krypton rarely forms a compound, but every once in a while it does. The reason it normally doesn't form a compound is because it is a noble gas. But anyways, krypton's by itself, so it's just krypton. It's not monocrypton, remember, because it's the very first element. If it was the second one, then you would have to use mono. But I have 4 fluorines, so the prefix for 4 is tetra, and fluorine's name turns to fluoride, so Fluoride for krypton tetrafluoride. Looking at the next one, PF6, P is phosphorus, F is fluorine. Both are nonmetal, so this is covalent. Covalent means we use prefixes. So let's start with phosphorus. I don't have to use mono because it's the first one. Otherwise, I would if it was the second one. And then I have 6 fluorines, so that's hexa is my prefix for 6, and fluoride. Hexafluoride. And last but not least, CuBr2. Cu is a metal, it's copper. Bromine is a nonmetal, so a metal and a nonmetal means it's ionic. Now, if I look up copper on my ion sheet, it's not just copper, but copper can have more than 1 charge, so I'm going to need that parentheses. Bromine turns to bromide. Notice I didn't call it dibromide because it's an ionic compound. I don't use prefixes. But here's the deal. We have to figure out what the charge is on copper. So according to the formula, there's 1 copper for every 2 bromines. Well, each bromide ion, if you look on the ion sheet on their bromide, has a -1 charge. So if they have a -1 charge, what does the copper have to have in positive charge to cancel out? It has to have a +2, right? Because +2 charge cancels out with 2 negative charges. So that means that copper has to have that +2 charge. So we would call it copper 2 bromide. All right. Hopefully for this top part, this made more sense to you and that you're feeling more and more confident. You should be able to do this for your quiz, definitely. Tell if it's covalent or ionic, and also how to properly name it as well. For the second half of this sheet, we have now the names, and we have to figure out if it's ionic or covalent. Quick thing, remember, if it's covalent, it's going to use prefixes. If it's ionic, it's not going to use prefixes. It's going to be a metal and a nonmetal. So let's rock that out really, really quick. In fact, let's go down the list. Nitrogen trioxide, tri is a prefix, so this is covalent. Sulfur pentafluoride, penta is a prefix, so it's covalent. Copper 2 oxide, no prefix, and copper is a metal. Oxide is a nonmetal, or oxygen is a nonmetal, so that's going to be ionic. Diphosphorus tetrasulfide, those have prefixes, so this is covalent. Strontium phosphide is a metal and a nonmetal, so that's ionic. Nitrogen heptafluoride, prefix, so it's covalent. Magnesium sulfide is a metal and a nonmetal, that's ionic. Iron 3 nitride, iron's definitely a metal, so this is ionic. Carbon tetrafluoride has a prefix, so that's covalent. And rubidium selenide. Rubidium on the periodic table is a metal, so this must be ionic. All right, so when we write the formulas, we will love the covalents because the name tells you how many of each. So for example, nitrogen trioxide, there's one nitrogen, and trioxide means oxygen, and there's 3 of them, NO3. So we love writing formulas for covalents. The name tells you how many. Next is sulfur pentafluoride. Sulfur is by itself because it would have said more, like disulfur if there was 2. And pentafluoride is fluorine, and penta is 5, so SF5. Good, good, good. Next is copper 2 oxide. Okay, copper 2, let's do some side work really quick because for ionic compounds, we have to figure out how many are going to come together. So copper 2 means it's 2+. If I look at oxide on my ion sheet, it's always 2-. Ooh, this is nice. +2 and -2 cancel out to make 0. So that means I'm only going to need 1 of each. So this is CuO because +2 and -2 cancel out. So you only need 1 of each. Looking at our next one, diphosphorus tetrasulfide. Diphosphorus, di means 2, so there's 2 phosphorus. And sulfur is sulfide, and tetra is 4, so P2S4. For my next one is strontium phosphide. Okay, well, let's figure that out. Strontium, if I look on my ion sheet, strontium has a 2+ charge. If I look at phosphide, phosphorus on my sheet has a -3 charge. All right. So I've got to find a way to balance these out. No problem. If I do 2 phosphides, that's going to give me -6 charge. So I know I can get to +6 if I use 3 strontiums. And that's what I got. +6 and -6. So in order to balance out, I am going to need to use 3 strontiums for every 2 phosphides. So 3 strontiums, Sr3. Phosphorus, I'll put 2 of them, Sr3P2. Not too bad, huh? We just have to find the charges, balance them out to 0, and write how many of each it takes in order to balance out to 0. Next one, nitrogen heptafluoride. Nitrogen's by itself, so N, nitrogen. Hepta means 7, so I have 7 fluorines. Wow, NF7. Good, good, good. Next one is magnesium sulfide. It is ionic, so we've got to figure out their charges before we can draw their formulas. Well, magnesium off my ion sheet when I looked it up is +2. Sulfur, when I look on my ion sheet, which is the sulfide ion, is -2. Ah, look at that. +2 and -2 naturally cancel out. So that means I only need 1 of each. That's nice. So it would be magnesium sulfide, MgS. Awesome. Next up, iron 3 nitrate. Okay, we could do this. Iron 3 means that it's Fe3+ charge. That's why they have the 3 there. Nitrite is nitrogen. Nitrogen, when I look on my ion sheet, let's take a look. Nitrogen has a 3- charge. Oh man, we are getting lucky. +3 and -3 balance out. I like that a lot. That means it's just Fen for iron, 1 iron, and 1 nitrogen because each balances out. Next is carbon tetrafluoride. Well, it's covalent, so carbon means there's 1 and tetra means 4. So there's 4 fluorides. So CF4 because 1 carbon, 4 fluorines. And last but not least on this page is rubidium selenide. Okay, rubidium is a metal. If I look that up on my periodic table, rubidium is in the first column of the periodic table. That is a +1 charge. Okay, selenium, Se, which is a nonmetal, selenide, has a 2- charge. It's the same charge as oxygen and sulfur because it's in the same family. But anyways, selenide has a -2 charge, so that means I'm going to need 2 rubidiums to be able to cancel out, right? +1, +2 to cancel out with the -2. So I will need 2 rubidiums for every 1 selenium. But now that we've completed it, hopefully you're feeling more confident and comfortable determining if it's covalent or ionic, and also being able to write out the formula, understanding how ionics and covalents are written differently. We're coming towards the end of our review here. Let's brush up with a couple quick questions. What type of bond transfers electrons? That's going to be ionic for sure. Remember, in order for something like sodium and chlorine to get that +1 and -1 to come together, they had to transfer the electrons in order to make that happen. Sodium had to lose an electron and transfer it to chlorine to gain an electron to have that +1 and -1 charge. So ionics transfer electrons. Now, who shares electrons? That is the covalent bonds, right? Covalents do that. If you recall, something like oxygen shares 2 pairs of electrons in between it to make what we call a double bond. But you have to share electrons in order to stay together. Ionics are stronger bonds than covalents because ionics are come together because of that electrostatic difference in charge, where covalent bonds stay together because they're sharing between them. We look at the next one here. I'll just say it instead of write it all out. But what traits do covalent compounds usually have? Remember, because they're weaker bonds, they usually have low melting points if they are solid. So they're easily melted, but usually they're a gas or a liquid. And covalent compounds are always nonmetals. So those are all traits you can think of. As far as ionic compounds, what are the traits they usually had? Well, there's usually a metal and a nonmetal, right? They tend to be solid, and when they are, they tend to be brittle or crumbly. Think like table salt. And also remember, they're usually soluble in water, meaning they can dissolve in water. And when they do, they become electrolytes, meaning that they can conduct electricity. So those are all traits of ionic compounds. And number 25, we've been hammering home, but let's make sure we understand. What compound is a molecule? That's a covalent compound. What compound is called a formula unit? That's an ionic compound. All right, so we've reviewed a lot with naming. We call that all writing formulas and naming the nomenclature, and we're understanding the difference between ionics and covalents. Great job today, science fam. Best of luck, and let me know if you have any questions.